Okay, so this is our second video about interpreting graphs of functions. As you see, it says part 2. So if you missed part 1, go back and find that one. But so to begin with, right, g of x and f of x always are representing the y values from your given function. Okay, g of x and f of x are always y values. The y values from the f graph or from the f equation, and then the g are the y values from the g equation. So each of these are representing y values, but they are coming from different places. So we either have an equation for f and g, or like today, we're going to have a graph for f and g. Okay, so if f of g equals g of x, graphically, what does that mean? So here, if your y values are equal, that means that your graphs are intersecting, right? The graph of f and the graph of g intersect at this specific y value, right? So we can figure out what the x value is when these two graphs are going to be equal. Okay, so graphically speaking, what if the f of x, the y values of f, are greater than the y values of g? Okay, so that means that the f graph of the f function is above the g graph. Okay, the values of f are greater than the values of g, so the graph itself is above. And similarly, if it goes the other way, if g is the one that's greater, then the g graph is going to be above the f graph. G graph is above the f graph. So we're going to talk about, right, and how do these relate to each other? Which one is above, which one is lower than, and then of course we'll be doing some operations on those, adding, subtracting, multiplying, and dividing and such. Okay? So f of x and g of x can only be compared on the interval blank, because that is the interval of values where both graphs exist simultaneously. So in order for us to compare them, the domains have to overlap, right? Because we can't have an x value that belongs to f that doesn't have one that belongs to g. So that we can only compare them if they are actually overlapping. Okay, so here are some pictures. Once again, we have the points where f of x is equal to g of x. And it says identify the x values for that plot. So where do these graphs intersect? So those are the x values where your y values are the same. Remember, f of x and g of x are talking about the y values. Okay, what's it say below? Oh, nope. Identify the x values for the highlighted portion of the graph where the f is greater than the g. So let's see, which graphs are which? What does it say? Does it tell us which graphs are which? F is the dashed line and g is the solid line. So this is g as the solid and f is dashed. So where are the places where the f graph is above the g graph? Okay, so here we have some parentheses, right? We're always using these parentheses, and then 5, 2, 7. So we have two intervals where the f graph is above the g graph, or f of x, the y values from f are greater than the y values from g. Okay, and since we have two separate intervals but only one answer, we combine these intervals with this u, which stands for union of these two intervals. And then our third one is where is the g values greater than the f values? Okay, so all of these places from, right, so here are the places where the f graph is less than, or rather the g graph is bigger than the f graph, from -2 to 5. Is the interval where the g is greater than, or the f is greater than, the f is less than g, or g is greater than f, depending on how you want to say it. Okay, so intervals where one y value is greater than the other y value. So should your intervals be closed intervals or open intervals? And of course they're going to be parentheses because we don't want to include equality. Okay, we don't include where they are equal. We are including where one is strictly greater than the other one. So we only use parentheses. So lastly, we can put in the domains. So these are the domains of f and your g value, right? The x's from left to right, and these are the ranges of your f and your g value from top to bottom. So notice that the g has an extra thing that the f doesn't have, so we can't actually compare the graphs when x equals 5, because f doesn't have a point when x equals 5. Okay, so let's see, what else do we have? Okay, so we're asked to do some writing here, right? We're asked to write the words, what you're asked to find. So if we're asked to find all the values where f of x is equal to 0, what are they asking us to find? The y values which are on the x-axis. Okay, so if y equals 0, all the points where y equals 0, we're looking for all those points on the x-axis, or where it crosses, where your graph crosses the x-axis. Okay, that's what it means if y is 0, it's crossing that x-axis. So let's look and see. F is the dashed line, it says. F is dashed. So it crosses the x-axis at +1. And anywhere else? Right, if we could continue on with the thing here, it would again cross at 15, right? So even though it's not explicitly given to you on the graph, our arrow is meant to assume that it continues on here forever in that direction. So eventually, because it is an increasing function, right, that's an increasing interval, the graph would in fact cross. So x equals 1 and x equals 15 are the two x values from your graph where y is 0. Okay. Similarly, what does it mean for the g of x to be equal to 0? Okay, that's where your g graph crosses the x-axis. Okay, so g of 0, so we have one, looks like, at a half place perhaps right there, maybe? Maybe that's a half? Yeah. Close enough, even if it's not. So we'll call it -4.5. We could probably calculate that, but this is good enough for now. And at 6 and at 10.5. So all of these are the x values where your g graph is crossing your x-axis, where g of x equals 0. And then our last question, where the f of x equals the g of x. Right, so these are where your y values are equal. Where are those graphs intersecting, right? That is what it means. Where do these graphs intersect? And it looks like they intersect at, oh, this is not a very adorable point, but let's estimate it. -1/2 or even less than, if you're thinking. Negative, maybe, I don't know, what should we call this? Who cares? Whatever you want. You can put whatever decimal you want there between 1/2 and 0, so something, right? Whatever your interpretation is. And then again over here at x equals 9. Okay, is where they touch again, right? Not actually crossing, but they do happen to intersect. Okay, so remember, all of these answers are x values from your graph. We're not talking about what the y is. We're just talking about what is the x value where the y is behaving in this way. Okay, so we have 3 other ones. Our first one, where is the f of x less than g of x? Where is f of x greater than g of x? And then where is your y values from f above the x-axis? Okay, so let's write those down too. So here are your intervals, right? The purple is where the f graph is below the g graph. So from our intersecting point there all the way to where they touch again, right? So we exclude the point 9, and then from 9 to wherever g ends, because we can't compare g and f if there's nothing from g to compare. Okay, and then the next one, where are the y values from f greater than the y values of g? Okay, and that happens from -9 to wherever they intersect. And then this one just says, where is f above the x-axis, right? Where are the values, the y values from f, positive? So positive till you get to +1, and then again from 15 on to infinity, because your graph is increasing forever. Okay? All right, one more page, and these ones are stuff that we probably haven't seen yet, so we'll make some other notes. So our next one says something about f. Find the values of x where f of s is increasing, right? So the y values are getting bigger from left to right. We're always looking from left to right. No matter what your arrows say, our intervals of increasing and decreasing always go from left to right. And then we're going to have the values where f is decreasing, and then we're going to have the values where f is constant, if any, right? And if these aren't happening, then you always write none. So those are your intervals of increasing and decreasing, right? And then constant, anything that's horizontal is constant. We are not increasing or decreasing, and we never include the endpoints where it's changing either. Okay, so we always have parentheses when it comes to increasing and decreasing. And what's next? Find the values where f of x is less than 0. And then we'll just do that one real quick, hang on. Which has an interval from 1 to 15. So I'm going to overlap here. So this is the spot where your graph is below your x-axis, where your y values are negative. Okay, that's what it means to have f of x less than 0. Now let's look at this next one, because we haven't been multiplying these. What has to be true in order for the product of two numbers to be less than 0? Right? One of them has to be negative. Can they both be negative? No. So only one can be negative. So we are looking for places where either the f graph is below the x-axis or the g graph is below the x-axis, so that the product of their two things is negative. Okay? So we're looking for one only. Where is that happening? I'm going to erase the rest of these lines real quick. So from -11 to 4.5 is what we said, right? G, this is the graph of G. G is negative. So we have negative y values from G times positive y values from F. Well, hang on, wait a second. Can we go all the way to -11? No, we can't, because there aren't any F values there. So we need to start at -9, right? Because there's no f values between -11 and -9. So we can't include those because that's not in the overlapping domain. So here on this interval, one of our functions is negative. And then again from 1 to 6, right? Here your f function is negative. So between 1 and 6, their products will also be negative. And then between this tiny thing right here, right? This is your last interval, and that tiny little area between 10.5 where your G graph is above the x-axis and your F graph is below. So we have three separate intervals where our graphs are in opposite places. One is above and one is below. So their product is going to be negative because only one of them can be negative to give us a negative product. Okay, so let's write that interval. So there is your one answer represented by three intervals of choices there. Okay, so then our next one says, when is their product going to be positive? Okay, so if we have two numbers that multiply together to give you positive, either both of them are positive or both of them are negative. So we're looking for places on your graph where both of your functions are above the x-axis, or places on your graph where both of your functions are below the x-axis. Okay, both above or both below. So So let's see. Let me erase this red one so we can start fresh. Okay, both of them are above the x-axis from negative 4.5 to positive 1. So here is one interval where they're going to have a positive product. And then we have both of them negative from negative 6 to 10.5, right? So both of them are below the axis between positive 6 and 10.5. So two intervals where the product of these functions' y values will be positive. Either both of them are negative, both of them are below the x-axis, or both of them are above the x-axis, gives you a positive product. Okay, so interesting to think about that we're using all of these y values to then do some math and compare the y values from your function. Okay, so hopefully things are clear and everything's good. Okay, goodbye.